Hi there, my name is Sidney Shapiro, and we're going to do a quick video today about if statements and nested if statements. And really, that is not as scary as it sounds. This is a really easy way to figure out what kind of data we have and to sort through it and to take data and to make it more usable or to put it in a different form to interpret it. So basically, this is what we're talking about. We're telling Excel, take some kind of check that square, check that cell, and if it's raining cats and dogs, then close the window. Otherwise, go to plan B. And we're going to tell it what plan B is. But it's basically this three-step process. The command we're telling it is if. So if this is true, then do this, otherwise do that. Now, if the first thing was not true, then we would skip to the third step, right? So it's pretty simple. It's basically if this is true, then do this, otherwise do that. Okay, and we'll look at a few examples of how that works. So here I have 3 examples set up, and we'll go through them one at a time. And the first one, and this is very common, in our program, if you're 18 or under, then you're eligible for our program. But if you're 19, you're not. So we have a column with everybody's ages, and we could compute these off of people's date of birth, like you could see in one of the other videos. And we want to know whether people are program age or whether they're not. Now this is really, really simple to figure out, so I'll just zoom in a little. This is how I set it up. So I said equals to tell Excel that I'm making a formula. If, and you'll see underneath there's this little pop-up that comes out, and it has 3 components. It has the logical test. So I said if, and then I put in a bracket to hold all our numbers, A2, which is this square that says 16, is less than or equal to 18, so 18 and under. Then I put a comma, and in the bracket, in the apostrophes, I put program age in the quotes. If that's not true, so if the person's over 18, then put in too old, right? So once I do that, so I just type in equals if bracket the operation that I want it to have. So here it's checking if A2 is 18 or less, then put a program age, otherwise put too old. Okay, so I type enter, it puts in program age. Now if I drag down on B2, it's going to extend that down for each one. So here we could see it automatically made it A3, A4, A5. Then we got to A6, 19 is greater than 18. So it went to the third piece, which is too old. Okay. So again, it's really easy to do it, to put it in. All you do is type in equals if, and right away it comes up here and it knows that Excel is going to ask for some numbers or some commands. And the first thing is our logical test. So let's say we wanted to say, check if this square is greater than 15. Okay. Now, if it's true, so that square is greater than 15, say great. Otherwise, say not so great. Okay, now we scroll down. Everybody's great. If I change these numbers, it will automatically change, right? So the cool thing is that once we have all these results in, we're able to, using some of the other lessons that we've learned, quickly categorize these results, right, and see how many of them there are. So for example, we could just grab those and make a quick chart, which would show us the difference in the category. So instead of looking at 20 individual numbers, here we actually group them into whatever the category that we're looking at is. So program age, not program age, etc. So let's look what this likes with program age. Okay, so most of our participants are program age, and this is what the graph would look like if we wanted to put in our report, for example. There's a lot of other things we can do with this, just gives you an idea. This is obviously really useful if you want to put in a score, right? So here I said if D2, which is our first score, is greater than or equal to 50, then you pass. So if you get 50 to 100, you pass. And if you get 0 to 49, you fail, right? So we could just drag it down and we see that showing up. Now you'll see that the person who scored 50 passed because it was 50 and above. But if we got rid of this equals, then this would mean if D2 was greater than 50, meaning 51 and above, then you fail. So now if we drag it down, you'll see that the person who has 50 failed. That's why it's important to keep that equal sign in there if that's what you actually mean. Okay, that's great, except the obvious other thing we would use with this is a letter grade, right? How do we do that? That's the problem. So we want to basically say if you got 80 to 100, you get an A. If you got 70 to 80, you get a B, and so on, right? And we'll look at that in another example. So instead of having our three-part if statement, right, like we see up here, if, then part one is what we're checking for, part two is what happens if it's true, and part three happens if it's not true, we're going to do something called a nested if statement. So basically what we're going to do is we're going to repeat the third part. So it really looks like this. We're going to say if this thing is true, then do something. Or, and then we're going to do a second check, right? Or a third or a fourth. So let's look at that up here. It's a little intimidating, but it's really not that complicated. In this one, we're looking at if G2, so that's this number one that we have here. If the answer was 1, then write not interested. If it's a 2, then write maybe. And if it's a 3, then write yes, interested. I just realized that this should be on a scale of 1 to 3. And that's how you know that it's not perfect. All right, so imagine you have a survey and people are circling 1 to 5, let's say, but then you want those results to be in your document. You just want to type in 1, 2, 3 to save time, but then you want to bring back the original names. You don't want to have to type in all this. Okay, so the easy way to do it would be just to put in the numbers and then put what they represent, and then we could just grab a quick chart, and then you could throw that into a document or something else, right? So again, the way to actually do that is, let's work on our first number, right, which is G2, sorry. So we say if G2 equals 1, then write not interested. Now, the comma, normally we would put what happens if it's not true, but instead we put another if. So then we say if G2 is a 2, then put in a maybe. If that's not true, put in another if, and say if G2 is 3, yes, I'm interested. Now, it's really important to notice here at the end, over here, we have 3 closing brackets because each one is nested inside the other, right? So this is the first one, the second one, and the third one, and you can nest this as many times as you want in order to put in multiple options. So for example, let's say you had letter grades A to, F. For A, you would say if G2 is greater than or equals to 80, then write A. If G2 is between 80 and 90, then make a B, and so on, right? So now when we grab this, we pull it down, we get the same kind of thing. Really quick and easy chart. And this breaks it down really, really simply, right? So we're able to really quickly analyze those responses instead of dealing with what could have been otherwise. We could have hundreds of numbers in these columns, right? So whether you're doing scales or scores or ages, or even looking for different kinds of text, nested if statements and if statements are a really, really easy way to sort through that data and make it more readable, right, in order to present it. I hope you learned something. I definitely did, and thank you for listening. Hopefully we will go through a whole bunch more. Have a great day.